Hello, grade 12s. Welcome to Amelia Academy. This is Onami Jengeta, and it's so good to be with you again. So today we will be doing exponential function. Exponential function, that means it has something to do with an exponent, okay? So what is an exponential function? Exponential function is a branched function. It's a branched function with just one piece, okay? One piece function, one piece function, okay? One piece function. It has only one asymptote. Sorry about that. One asymptote, which is your horizontal asymptote. Let me just write it here. Horizontal asymptote. Okay. So yes. So as you know that each function has its original form. It has its original standard form. Okay, the standard form, the original standard form of an exponential function is y is equal to a to the power of x. Okay, remember an original function or an original standard form has to do with the function with no shifts. All right, where you are only dealing with the Cartesian plane and that kind of function. Okay, so in this standard form, your x-intercept has acts as your horizontal asymptotes. You will see. I'm gonna draw it for you in a minute. Asymptotes. All right, and then where will the graph pass in this standard form? Okay, so in this standard form, or in the original function, your graph will always pass to the point. Your graph will always pass through point 0 and 1. How? Let me show you how. Okay, so you know that when you're looking for y, your x should be equal to 0, right? Okay. Oh yes, so it's gonna be a to exponent 0. You know that any number or exponent to the power of 0 is equal to 1. So y is equal to 1, right? So when x is equal to 0, y is equal to 1 in an original function. And then here is okay, so let me draw it for you. Okay, just a small piece, just a small illustration. Okay, this is your x, this is your y. We're gonna have a time where we will do just the exponents, grade 12 exponents. All right, so here, so x is equal to 0 and 1 is y is equal to 1. So the graph will pass here. All right, so and then what about the shape? If a is greater than 0, the graph will be increasing. Its shape will be like this. And then if a is less than 0, your graph will be decreasing. Okay, so now that a here is positive, so it's gonna pass here. Remember, I taught you how to read the graph, how to know if it is increasing or decreasing. Remember, you read from your left. So from your left, it started here, and then as we go to the right, it increases, it goes up. All right, so that's how you tell. Okay, so what happens if there are shifts? What happens if there are shifts? Okay, so remember, in this graph, here is your asymptotes. Remember, an asymptote is a line where the graph doesn't touch or pass through. Okay, so now if there are shifts, you find a new standard form, which is y is equal to a into x, minus p plus q. Okay, into x minus p plus q. So these are shifts. This is your shift and this is your shift. So p is your horizontal shift. And q is your vertical shift. All right, so if p is greater than 0, your graph will shift to the right. If p is less than 0, your graph will shift to the left. And then if q is greater than 0, your graph will shift upward. And then if q is less than 0, your graph will shift downward. Okay, all right. So which one is your horizontal asymptote? Which one is your asymptote? Remember, I told you that an exponential function has only one asymptote. So q will be your horizontal asymptote. Q will be your horizontal asymptote. All right. Okay, so now we have to sketch the graph. So now we are sketching the graph. Okay, let's say they say f at x. Remember, this is a functional notation, this one. Okay, it's the same as y. All right, so f at x is equal to 2 to exponent x minus 1 minus 4. Remember, I told you that when you're sketching the graph, you should just follow the rules. Okay, do your workings aside before sketching the graph. It's very important for you. In fact, it's compulsory for you to do the workings before sketching the graph, so that you can get the points and whatever you're gonna need to sketch the graph. So you start with the shape. Okay, and then which letter represents the shape? A. So I said that if A is greater than 0, so you can see that A is greater than 0, and this that means your graph will be increasing. Okay, it's like a mark or so, but not exactly a mark. Okay, so what else? Your asymptote. Your asymptote is q is equal to -4. All right, and then your x-intercept, they will always be the x-intercept no matter what. So for x-intercept, remember, you let y equal to 0, so it's gonna be y is equal to 2 to exponent x minus 1 minus 4, and then 0 is equal to 2 into exponent x minus 1 minus 4. And then what else? From here, you try and solve the question and get the value of x. So now what you can do is to transpose this 4 to the other side. So it's going to be positive 4 is equal to 2 to exponent x minus 1. And then you know the rules for the exponents. you have to make the bases the same. So if the bases are the same, that means the exponents are also the same. So it's going to be 2 to the power of 2. 2 to the power of 2 is 4, right? So is equal to 2 to exponent x minus 1, and then the bases are the same. That means it's going to be 2 is equal to x minus 1, and then you transpose the 1 again, so it's going to be 3 is equal to x. Okay, so the point is 3 and 0. Okay, so for y-intercept, you let x equal to 0. So it's going to be y is equal to 2 to exponent x minus 1 minus 4. So y is equal to 2 to exponent 0 minus 1 minus 4. Alright, so y is equal to 2 to exponent negative 1 minus 4. Alright, 2 to exponent negative 1 is y 1 over 2. Alright, you can punch that using the calculator, or I'm gonna do a study about this. So I'm gonna do a lesson about exponents so that you can understand how I came about having this half. So half minus 4 is, negative 7 over 2. So you should convert it to a decimal so that you can know which point is this. So negative 7 over 2 is negative 3,5. Alright, so the point here is 0 and negative 3,5. Okay, so now you can sketch the graph. I'm gonna do it aside because I want you to see. Okay, we have, okay, remember, I always tell you that when sketching the graph, always make sure that it is as accurate as possible. This is your x, this is your y. So let's just let's first plot these points. So it's 3 and 0, so I'm gonna assume that 3 and 0 is here, and then 0 and negative 3,5 is here. 3,5, I'm going to assume that negative 3,5 is here, and then let me expand this, and then 4 is here. So 4 is your horizontal asymptote. Remember, you represent it by dashed lines. Okay, dashed line. So your point is, your graph will look like this. You join the point, it will look like this. Remember, it comes closer to an asymptote, but it never touches it. So you then write the function is equal to 2 to exponent x minus 1 minus 4. So that's all about sketching the graph. Okay, so now we have to find what we call as a domain and a range. Remember, a domain is where a graph exists in x-axis. So the graph exists here, domain. So where the graph exists in x-axis, okay? So the graph exists from here and upward. Okay, so you can say that x is an element of real numbers, okay? And then for a range is where a graph exists in y-axis. So range you can put it in coordinate form. So a graph axis starts from here and all the way upwards for the y-axis. So you can say that a graph starts from -4 to infinite all the way up here. Remember, this arrow means that the graph can go up as far as possible. Okay, so now we have to do to find an equation of an exponential graph. Okay, so now we'll be required to find an equation of an exponential graph. So I told you before that in order for you to find an equation, you have to be given something. It's whether the points or asymptotes or whatever you should be given, so that it can help you to find an equation. So in this case, I want you to note, grade 12, that in this case, in an exponential function, they will give you they will give you an asymptote, right? And they will give you 2 points. Okay, why 2 points? Okay, so in an exponential function, in order for you to find an equation, you should be given a graph at least, so that you can see. But what I can tell you is that, you see, they don't normally use this format, this one, into x minus p plus q, in order for you to find an equation. But they introduce this one, y is equal to a b into x plus q. All right, so they don't normally assess you with this one, but this one. So whenever you are asked to find an equation of an exponential graph, I want you to do it the way that I'm going to show you, and I want you to write it. So whenever you are required to find an equation of an exponential, I want you to do this, to find it according to this standard form. All right, so let's say you are given an asymptote y is equal to 1 and 2 points, 0 and 3 and 1 and 7. Okay, so this one, you have to be careful when you are given 2 points like this. Okay, let's start by substituting the asymptotes first, so that we can know what we don't have. So the asymptote is +1, this one. Okay, so now you have 2 points, and you're gonna use them both. You're gonna use the first one to find the value of a, and use the second one to find the value of b. All right, so you have to be very careful with this one. I always tell my students that when you are given 2 points like this, start with the point that has 0 as your x value. Start with the point that has a 0 as your x value. Why? All right, so which point in this one? This is the point that I'm talking about. So y is equal to 3, and a, b, and x is equal to 0. Okay, plus 1. Why did I use this point first? Because you know that any variable or number raised to the exponent 0 is equal to 1, right? And then in this case, this 0 only affects b and not the whole term. Okay, so it's gonna be a into 1, b to exponent 0 is equal to 1 plus 1. All right, so now you found the value of a. You already found the value of a. is equal to a plus 1, and then you transpose the 1 this side, so it's going to be 2 is equal to a. All right, and then find the value of b. Now you can use this one to find the value of b. You already have the value of a, so it's going to be y is equal to 2b to exponent x plus 1. Okay, now substitute the second point to find the value of b. So it's going to be 7 is equal to 2b to the exponent 1, right? Substituting this point plus 1, right? And then you transpose the 1 to this side, it's going to be 6 is equal to 2b. And number raised to the exponent 1 is that number or variable. And then you divide by 2, you divide by 2, so 3 is equal to b, right? Okay, now you can substitute everything that you have calculated to your equation. So y is equal to a b x plus q. So y is equal to, what is your a? 2, and your b 3 to exponent x plus 1. So this is your standard form. This is your equation, right? So okay, so in summary, you use this standard form, and definitely they will give you an asymptote and 2 points. All right, it's whether by a graph, or they just gonna mention points like this, or they're just gonna write the points. Okay, and then you find the value of a first using the point that has the 0 as your x axis, as your x coordinate, right? As your x coordinate. Okay, so and then you substitute and find the value of a, and then use the second point now. All right, and then substitute and find the value of b. That's it. It's as easy as that. Thank you for watching. Please do not forget to like, subscribe, and share this video to whoever who might need it. You know, your friends, you know, anyone who might need the video. And then yeah,